Chapter 2, Lesson 3, Multiplying with Scientific Notation. The key concept for today is that the rule for multiplying powers with the same base applies to multiplying numbers in scientific notation. So if we review Chapter 2, Lesson 2, Exponents and Multiplication, and we take, for example, 3 squared times 3 to the 7th power, the base, which is my 3, stays the same, and we add the exponents together, equaling 3 to the 9th power. So we're going to take that idea and now we're going to apply it to scientific notation. So here in example 1, I have 5 times 10 to the 6th power times 9 times 10 to the 23rd power. The first thing I'm going to do is I'm going to use the commutative property to rearrange my numbers, and I'm going to use the associative property to put these in order so that my bases are together and so that the times 10 to the 3rd, the scientific notation, is together. So let's rearrange these so that I have 5 times 9 times 10 to the 6th times 10 to the 3rd. So I have grouped 5 and 9, and I have grouped 10 to the 6th and 10 to the 3rd. So then I can solve. 5 times 9 is 45. Keep the parentheses. Ten to the 6th plus 3, which equals 45 times 10 to the 9th. Sorry, this got erased a little bit here. So, to recap, I used the associative and commutative properties to regroup 5 and 9 together, and then 10 to the 6th power and 10 to the 3rd power together. I multiply my exponents, keep the base the same and add the exponents, and come up with 45 times 10 to the 9th power. Okay, example 2. Example 2 reads, a light year, the distance light travels in 1 Earth year, is about 5.9 times 10 to the 12th miles. This number right here. A mile is 5.28 times 10 to the 3rd feet. How many feet are in a light year? So I need to multiply the feet, the number of feet, times the number of miles. So I'm going to use the same commutative property and associative property. And I'm going to group 5.9 and 5.28 together. 5.9 times 5.28 and multiply that by the numbers with the exponents. 10 to the 12th times 10 to the 3rd. So 5.9 times 5.28 is 31. Oh, let me change color. 31.2 10 to the 12th plus 3 is 10 to the 15th. So I have 31.2 times 10 to the 15th. However, in scientific notation, my number has to be between 1 and 9.99. Greater than 1, less than 10. 31 is greater than 10. So I need to move the decimal one more place to the left. So I have 3.12 times 10 to the 15th plus the 1 space I moved my decimal again. So my final answer is 3.12 times 10 to the 16th feet. So again, where did this 1 come from? This 1 exponent came from moving my decimal one place so that my number is less than 10 but greater than 1. Okay, example number 3. Choose the most reasonable unit to describe the quantity. So, it says the mass of a nickel is 5 something. The grams or milligrams. So the mass of a nickel is about 5 grams. But I want to convert grams into milligrams. And 1 gram equals 10 to the 3rd milligrams. So I'm going to convert. So 5 grams times 10 to the 3rd milligrams per 1 gram. So this line right here is the same as saying per 1 gram. Just like we can cross cancel, if I have 3 over, I keep clicking the eraser. 3 over 1 times 3 over 9, I can cross cancel. Just like I can cross cancel numbers, I can cross cancel units. So I can cancel my grams so that the only units left are milligrams. So I now have 5 times 10 to the 3rd milligrams. So I've just converted a nickel. The mass of a nickel is 5 grams, or 5 times 10 to the 3rd milligrams. Okay, the second one asks about a football field, the length of a football field. So let's make this say football again. So the length of a football field is 91 meters or 91 kilometers. Well, a football field is 91 meters long. This time I want to convert from meters to kilometers. Well, 1 kilometer is 10, excuse me, 1 meter is 10 to the negative 3rd kilometers. So just like I did crossing out grams, I can also cross out my units. So 91 times 10 to the negative 3rd kilometers. However, 91 is too big. My number has to be between 1 and 10. So I need to move that decimal one place to the left. So 9.1 times 10 to the negative 3 plus 1. because I'm moving my decimal one place to the left, I'm adding one place to my exponent. So 9.1 times 10 to the negative 2 kilometers. Okay, that's it for this lesson. Go ahead and complete your quick checks and check your understanding, and we will review in the morning.